The control surfaces comprise all the aerodynamic parts of an airplane that are used to steer the aircraft during the flight. They are divided into primary and secondary control surfaces. There are different types of control surfaces and mechanisms to maintain control of an aircraft in flight efficiently. The efficiency range of an aircraft changes depending on its speed. The primary control surfaces are responsible for directing the aircraft. These are the elevator to raise and lower the aircraft, moving the plane in its transverse axis. The rudder to control the yaw, moving the plane in its vertical or yaw axis. And the ailerons to control the roll or tilting the plane from one side to the other, moving the aircraft in its longitudinal axis. In case it is not clear to you, we'll review the axis of the airplane with this three-dimensional model. This is the transverse axis, the longitudinal axis, and the vertical axis. And the primary control surfaces are the elevator, the rudder, and the ailerons. Note that these axes converge at a specific point, and this is the point of the aircraft we call the center of gravity. It is the point where the aircraft is in balance. There is also the aerodynamic center point, but we can talk about that in another video. Then we have the secondary control surfaces responsible for modifying the lift that the wings generate or simply modifying the aerodynamics of the aircraft in other less conventional ways by either reducing or increasing lift as well as the aerodynamic drag. Among them, the flaps. These are similar to the ailerons, but they are closer to the fuselage and they have the task of generating more lift and reduce the speed at the same time. Depending on how much is the angle of inclination of the flaps, they can slow down the airplane even more or simply generate a little more lift during takeoff.